Now let's see a couple of examples of Minimax algorithm and how it operates. So this is a game tree with A, B, C, D, E, F, G nodes. So the first one, root, is played by max, and then the next is by the opposition, B and C by min, and then again max plays one more ply. So this is a 3-ply game tree, and then at the end the leaf nodes are the utility values produced. Okay, so we need to back up the values at every level and then make a decision at the root node which option the max should play. So the control will come over here. Let's show it with red. That control will come over here and then here, and then it's a DFS. So when we come to a 3, so we set the value of D to be 3. Okay, so and then this is played by max. So then control again goes back to the parent and then comes back this path, and then we see, oh, there's a 5, so that's better. So max can improve its utility. So 3 is changed with 5. Now the 5 is pushed back to the upper level, and then we write 5 here. But remember, this is a min. So before the min, the control will again come down this path and go up to the left child and find this is 6. So this is a max's turn. So max will first consider 6 as the value, and then it will go to the other child through the parent and find, oh, there is a 9. So it changes, max changes 6 to 9. So now 9 is also sent to the parent, and now you will see that this is min. So which one min will choose among 5 and 9? Of course it will choose 5, and 9 will not be chosen. Min's idea is to make sure max's utility value or max's profit is kept to minimum. So now this 5 is pushed to the next level, which is max here, and this we write here at max. This is pushed over here. So now the other side of the tree, this is not yet completed. The other side of the tree need to be explored. So it's DFS, so it will go all the way and come to F. Okay. So in the F left child, we see that this is 1, and this is a turn of max. So I write the 1 first, get this value, and then explore the other child, which is 2. So max will definitely go for 2 instead of 1. So now this value is pushed up to the node here, which is min. This will again explore this tree entirely and come up to down to 0. Since this is max, you initially get a 0, and then when you check the other child, you find this is -1. So 0 is bigger than -1, so 0 will be pushed, and then min will find at this level min's turn that, oh, 0 is less than 2, so I will change 2 to 0. Now 0 will go over here, but since this is max's turn, max will definitely choose a path which gives him 5 instead of 0. So 5 is the final value, and which path you get the 5? So you go this path, and then this path, and then this path. So this gives you 5. So this is the optimal path for this problem, right? Similarly, we have another problem here, which is also we need to solve using Minimax algorithm, and let's see how it works. It's working exactly same way. So the first one is max, then is min, then is max again, and then is min. Okay, so this is a 4-ply game tree. So 2 complete turns by max and min. So similarly, the control will come all the way down to the leftmost child, it's DFS, and since this is min's turn, it will get a 5, and then it will explore the next child, the sibling of 5, and it will find is 6. So 5 is chosen because 5 is minimum among 5 and 6, and this is pushed up to here, and then at this level the other child you will be explored through this path, and then 7 will be the first value, but this is a min, so it will find I have a cheaper value which is 4, and then when it explores the other value which is 5, you'll see that 5 is more than 4, so 4 is the minimum value. 4 is pushed up to the next layer, which is the parent, but this is played by max. So max has a utility value already known, which is 5, and now it has a 4. So it will never choose 4, and 5 will be the value. 5 will be now pushed to the immediate predecessor, and from there this entire path will be explored. Okay, so it will come to 3. So because this is just one child, minimum is 3, then it goes up this way again, maximum again is 3, and then when you send this 3 up here, this is a min node among 5 and 3, which it will choose. It will choose 3. So 5 goes out, 3 is sent to the parent. Okay, this is not finalized yet. We have not explored all the path. Now this is the second child. We come all the way down to 6, and then take that 6 because this is just a single child. It 6 comes here, and then the other path is also explored, and this is mean. So you get 6, 9, and 9 is explored, but 9 is higher. So 6 is sent to the parent, which is max, and both side gets a 6. So I just stick with a 6. Okay, either 6 is fine. And then this 6 is sent to the parent, which is a mean node, but this also needs to explore this other side, which goes up to 7. So we take a 7, and then we back up the 7 to the max, and then when it goes up here, a 7 and a 6 from the left side, of course a 6 will be chosen because this is a mean node, and then the 6 will be sent up. This is a max node, so 3 will be replaced with a 6. So I have a better path through 6. Now I check the right branch of from the root all the way. We go down to 5. This is a mean node, so I get a 5 here, push that 5 up to here, and even more higher to here. Okay, this is a mean node. Now this side of the tree needs to be explored. There's a mean node, so I initially come down to 9 and write a 9 here. Then I explore the other child and find I have a cheaper path, 8. Then I push that 8 to max. So max gets a 8 here, but from there there's another child. So so this is a 6. So we get a 6 from mean, but this is a max. So among 8 and 6, it will definitely choose 8. But next level, when I go up, I already have a 5, but max gives a 8 here. But this is a mean node, so it will choose 5 over 8. Okay. So now I send that 5 back here, but this is a max node, so we already have a value 6, so it will never choose a 5. So 6 is the final value, and let's see what is the path. So 6 is the final value. The path is this one, and then this one, and then this one, and then this one. So we got the minimax value of 6. Maximum would have been possible, which is 9, but because mean is playing optimally, it tried to keep it as max as low as possible, and the value was 6 instead of the lowest, which is 3.